Hey, good to see all three of you uh, coming up on the four. We've got four people on the stream right now. That's big ups to the four of you. That's always exciting. Very good. Very nice. We'll give it like a few minutes. This is a live stream, so you can kind of just join whenever. Mm, my background's getting all weird. Let's see if I can. I can't edit that away. Auto detect. That's much better. There we go. Someone's around. Much better. Much better. You want to make a special guest appearance? Yeah. Here we go. First time stream. Yes, this is my first time streaming on Switch. Oh, my screen's all messed up again. Oh no. This is a little someone here. This is my 6 months old son. Just turned 6 months today, actually. It's the second. So he's doing very good. He's having a fun time. This is his first time on Switch or Twitch as well. So he's having a good time. Looking at his mommy over there. Yeah. Pretty excited. What's happening? I know. I know. Someone's all jumpies. What's happening? Yeah? I know. Okay. There you go. Ah, better. His name is Horatio. Um, yeah, Horatio, little Horatio DeFranco. So maybe he'll be a Twitch streamer one day. That's the end all career goal for most Zoomers these days, or whatever generation he'll be. Who knows what that'll be? If there even is a generation in the future, who knows? Who knows? Maybe it'll be the next neural version of Twitch that comes out of your nose or something. I have no idea. Whatever scary, terrible technologies our future makes. Uh, Doing good. Well, we got 11 people on the stream today. Oh, the sound's a bit small. Thank you. Is that a little better? Is it a little louder? Can I go through that? My Westworld 2. Yeah, I know exactly. Westworld 2.0. Absolutely. Absolutely. Is that a little better? I'm a little more being heard, I hope. Okay. That's all. Yes. Thank you. Thank you for the feedback in the chat. Okay. Oh, I lost some people. I had 11 people on the stream. Now it's down to 9. I don't know what happened to two of our folks. I guess they just ran out or decided they had better things to do on a 5 o'clock on a Wednesday, as they probably should. If you know what that background is, I'm kind of surprised. Oh, you don't. You've ever seen the movie Midsummer? Familiar with it? It's Ari. Oh God, what's his last name? Ari, not Ari Smith. Oh God, I can't think of his last name in the moment. He's a famous director, um, and yeah, it's a really messed up horror movie with a bunch of Swedish people who it's like the small Swedish town that performs ritualistic sacrifice to ensure good harvest. So I thought it was relevant for our times in which we find ourselves in. So take that as you will. Things all there we go. Oh, that's like way too bad. Oh, that's not good. My chroma screen's like all screwed up. I can't like it like. Oh, that's better. That's a little better. Keeps getting a little messed up. There we go. Okay. Yes, it is a weird movie. I would not have want to watch it at 1 a.m. It is super trippy. It's like taking drugs or something like that. Like it's his like hallucination scenes and stuff like that are like the most crazy I've ever seen in a film. It's ridiculous and bananas. Okay, so I think we'll probably just get started with normal things. It's good to see you all. With our first Twitch stream, first time I've ever been on Twitch, first time I've actually really even used it. I've never understood the platform. I guess I'm too old to be in that to be in that mindset or to be in that demographic. I've never understood watching other people play games. I play games a lot. I'm a big gamer myself. So I've been playing video games since I was a child. I still play quite often. but I've never understood watching other people do it. Like I don't know, that's I don't know, just never like the appeal for me like doesn't make sense to me. Or like the non-gaming streams or even like weirder, you know what I mean? Like the live streaming and stuff like that, where people just like talk and complain or do stupid things outside or whatever. Like I don't know, it doesn't it seems weird. What games do I play? A little bit of everything. Right now, I just finished Near Automata a while ago. Amazing game. If you haven't played it, definitely do. That's one of my all-time favorites. Um, the whole Near series and stuff like that is genius. I'm going through Final Fantasy X remake right now, which is pretty nice. So I'm excited to dig into that. I remember playing the first Final Fantasy VII when I was like literally a child. So that's kind of been a trip to go back. So stuff like that, mostly like a little bit of everything. Uh, you watch it for esports? Yeah, I could see that. I watched a little bit of. I used to be really big into Overwatch. Like I was crazy into Overwatch. I was the Diva main, Diva and Mercy, or not? Well, not Mercy. A little bit of Mercy. Mostly Diva and what's my girl? May. I was a Diva and May main. Those are my two primaries, and I loved that game. So I used to watch some of the competitions and stuff like that. But I don't know. Overwatch is a weird one to watch. Like it's not very exciting to like watch it, I guess, than play. Um, so it's you know it's okay. Watch streamers for Fortnite and WoW mainly. I think people still playing WoW. That's ridiculous to me. I remember playing WoW a little bit when I was a kid. It's amazed me that's still going on. So that's pretty fun. Final Fantasy 14. Yes, that's true. I heard that. That's actually kind of really crazy. In fact, I was just playing the Soul Calibur, the latest Soul Calibur, like Soul Calibur 6 and B2 or 2B, sorry, is in it, and that was super fun. I loved playing as her. I always love any type of kind of carryover and stuff like that. So that's always fun. Okay, enough about about that stuff like that. If you ever want to play me in Overwatch, I could always kick up the Overwatch again. We could turn this into an Overwatch stream. Who knows? And you probably would destroy me. I've been so outside of the meta for like a year or two, so I have no idea if Diva is even any good anymore or anything with that. So that'd be fun. Yeah, I've been so outside the meta, and I haven't even played any like the new characters that came out or anything to go on with like Overwatch 2. I've been really following it, but yeah, good times, good times. Okay, let's hop over to our screen here. I've never played League. I've always wanted to, but I've always thought the community was like so toxic. In fact, they're literally academic papers written about the toxicity of League of Legends and like working with Riot to like deal with that. Like, what are some things in like game mechanic wise and social design wise to like fix that and like correct that. And there's been a number of things. In fact, there's even a bunch of things that Overwatch themselves, when they created some of the systems, some of the game systems in Overwatch stuff like that was purposely designed to encourage a more cooperative, less toxic community, like the play, the best play at the end, or other type of like rule mechanics and like how points are associated and like leveling up, and even how like the levels and stuff are laid out. It was like trying to be like the anti-league, anti-LOL in terms of like not having to be super dependent on other people and be able to have like your own skill sets and things. And there was like a lot of interesting social design in the action from like a game mechanic standpoint to like help that out, which I found was very interesting. It was a really interesting talk. So cool stuff. Epic, yeah, actually that's really weird. And there's a lot of, you're right, the Epic versus Apple lawsuit is really weird and crazy, and there's a lot of weird social implications around that and kind of the legalese. In fact, even like when I was talking, was it Tuesday? Yeah, yesterday. About like some like weird social, like weird lawsuits and stuff like that. Like this is the same idea around like Java as well, like who owns the platforms, who owns the things that kind of come from here, and kind of the areas where our technology comes from and stuff. Sun Microsystems and Oracle, trying to own or create licenses around Java, the language, messed up a lot of things. I mean, it came down to like there were even like lawsuits on literally like a 2 lines of code of like how you search over an index. You mean they're like trying to patent or like have copyright complaints around that, which is like insane. It's just, um, it's been crazy things to see what'll happen, but yeah, it'll be interesting to see with that. So I haven't played any other MOBAs, really just Overwatch, and that's because I just have my certain waifus that I'm into of Diva and May and stuff like that. I got stupid toys and figures. If you ever actually come to my actual physical office on campus, you'll find my little pops of Diva in her mech and May and a bunch of other stupid pops and toys, and I look like a child. So it's something to look forward to if we ever get to be in a physical space together in the future. So that'll be fun. Okay, so today we're talking a little bit about JavaScript. We're going to kind of go over some parts of the language as a whole, and some different elements, or not, actually not the language, that'd be way too much, but basically cover some of the things we talked about in class yesterday, and then like actually like some more practical ideas of like how to do some of these things. So I'm just looking at just a random webpage, not random, this is the JavaScript docs for Mozilla. Definitely check them out. This is probably some of the best documentation online about how JavaScript works and some other things around it. So definitely play around with this, but we're not actually going to be reading this or doing things on top of this. What we're going to be doing is using or whatchamacallit here. Let's clear that. We're going to be looking through the developer tools. So you just saw I just opened up developer tools on I'm using Chrome. Almost all the modern web browsers have some type of developer tools with them. You can always right click and inspect, or I think on Windows it's Command Shift I. On Windows it's also Command Shift, but it's like the little window command, not Control. Oh, sorry, it's Control Shift I on Windows. You don't have a command key on Windows. So you can kind of get the stage if this is like lets you kind of see behind the scenes of how these web pages are working. So this is probably gonna be like your best friend for this semester, at least when we talk about front end stuff. When we start getting like a back end code and Node, of course this isn't gonna be super useful because this is only on the browser and only on the front end stuff. So it's super useful for that. You could actually get this working on Node because the JavaScript engine that Node runs off of is V8, the same JavaScript engine created and developed by by Google for the Chrome browser. So they have the same JavaScript engine, and there's even a way to hook up like a local instance of Node running on your machine to like pop up like a version of DevTools to like do fun stuff with that as well. So just something to keep in mind. There's other debuggers and stuff like that for Node. We'll talk more about that when we actually start getting into fun Node stuff. So I'm going to first talk a little bit about the dev tools and some of the things that we're looking at and seeing, and just kind of explaining some of this stuff. And then we're going to like actually write a little bit of JavaScript and kind of take it from there. So dev tools are incredibly powerful. There's a lot of really great stuff inside of here. First and foremost, usually the first tab or the first pane inside of here and your dev tools is just showing you the elements. And this is the actual HTML of the document that we were just looking at. In fact, if I were to have this side by side and if you could see the web page and this at the same time, by highlighting these different elements and highlighting these parts of it, you'd actually see outlined on the web page what part of the web page that is, or like where that was found inside of that. So if you're ever curious about where in HTML is this button coming from, or how is this form being here and stuff like that, you can always right click on that or search through here and be able to see some of the stuff inside of here. This actually lets you to see and play around with the actual HTML inside of this document. Now, I know a lot of this might not make sense to you right now, but it will in the future when we start going later in the semester, near the middle or near the end of the semester, or actually more in the middle of the semester, we start talking more about front-end technologies, HTML, CSS, etc. But this is where you would start playing and like looking through some of these things. Here on the side, we see a bunch of the CSS for the site and kind of some of the things that are going through here as well. We can turn on some CSS elements on and off. We can see how that's going to change things. I can change and add. I could change the values inside of here to be something else. So this kind of allows you, this kind of elements page kind of allows you to kind of see some of the things that are going on and actually mess and play around with this. At the bottom here is the console, which we can also look further on in the next pane as well. And this is kind of where all the JavaScript console, whenever we do like console.log or other things like that, typically inside of here, this is what we'd actually be outputting to. And this is kind of allows us to write and do different JavaScript things. Also, like all of our errors and warnings and other kind of stuff usually shows up here as well. I could just kill that here. This is a page I could see always at the same time. I could also kill it and see what other things are going through. I can see a bunch of computed elements and stuff like that in CSS. So sometimes CSS is static or like created at that moment, or is very explicit written and stuff like that. But some of the elements or some of the attributes in CSS are computed in real time as things get changed or moved or other things around that. So we're seeing some of those elements inside of here. And then we're also looking at the different, we're going to talk about this in our CSS section of like how we represent, how CSS and HTML views elements or visual elements. All visual elements have a body, they have some padding between that, they have some, they have a border, and then they have a margin. And those are all different elements that we can have different spacing inside of, different colors, different things. We can use CSS and HTML to like change and modify all those little attributes inside of there. And also tell it how to position things around. Again, don't need to know that right now. Just kind of giving you a quick overview. We'll learn, we're going to go much more in depth into that later on in the semester. Our console page is where we can actually start. This is where we do a lot of our JavaScript fun stuff. In fact, inside of here, we'll play around with it a little bit. We can actually just write JavaScript, j equals 5, I don't know. And I could see, inside of that. And I would like to look inside j. Oh, what? It's 5. It lets me know like exactly what's inside of there. I could also do, this would be kind of dumb, but I could do like console log j. What? There it is. It's all good in the hood. Notice there's a couple things going on. This thing both outputted 5, but it also outputted this. This is also a function call. This function call doesn't return anything. Since it returned anything, it does still return something. It returns undefined. Remember, it's still a functional call. It's still a function call. So we're both seeing 5 because that's what this function is supposed to do. It outputs to the console. But it's also a function, and we always see inside the console when we write code directly into console, we always see end up what the end result of what would be returned from that. And of course, that function returns, it returns undefined. So we're going to play around with that a little bit in a moment. This is sources, where we can see all the different elements that make up this web page. I can see, I don't know, let me see. Let's see if there's any, this images build. JS, I bet there's some JavaScript inside of here. Yeah, so it's like React here. All this React code has been minified. What that means, most times when you're publishing actual JavaScript for other people or to be used live on a site in like a production system, you don't want to have all like the human readable stuff inside of it, because you humans don't need to read it anymore. You know what I mean? It's not something for you to write. And you have all these other spaces and invisible characters and like layout and like complex names and stuff. And that just like wastes data that could be shortened more. You know what I mean? So think of minification as almost like not compiling, because it's not like actually like turning it into bytecode. But it's basically a process to take out all spaces and carriage returns and invisible characters. So like all your code is on a single line. And then all the variable names and any like modifiable names and stuff like that get shortened to like a single letter. You know what I mean? Or there's some other way of like shortening those to like letters and single attributes and stuff like that, just to make that even smaller. So you can see like all these variable names and things like that don't make any sense. And this code is incredibly hard to read. You can always try to prettify this. Chrome Tools allows you to not really unminify, kind of unminifying that like it'll put back all like the invisible characters or like try to make that look nice and more readable, but it's not going to modify any of the variable or function names to maybe what they were before or something that's a little more clear and understanding. But it's a little more formatted, so it's still a little easier to read, but having it all in a single line like we had before. And so we're actually writing JavaScript, and this is just an example of something like that. We do a lot of cool things inside of here. We can actually run this. I can put in a bunch of breaks inside of here. Here I'm saying that if I were to rerun this page, it would stop the moment it got to line 11. And then I could look inside the scope and the call stack to see what's currently in scope, what's in the DOM, if there's any global listeners, which there should be. There actually are a ton of global listeners. Listeners are like a JavaScript way of waiting for an event to occur, something that's literally listening for something to happen and then does something else. So React is a web framework. JavaScript library. What's the difference between React and vanilla? Great question. Okay, so JavaScript on its own. When we usually say vanilla JavaScript, that we're talking about like just JavaScript with nothing else added to it, no external libraries at all. So it's just what you could put inside the browser, and the browser can understand and do things with that. That also includes a bunch of language like APIs and other type of like almost kind of like a standard library that comes with that JavaScript as a language normally comes with things like date and arrays and stuff to do with things with strings and other things like that. And it also depends like what version of JavaScript. Usually we mean like the most recent version of ECMA script, which in this case now would be like 2019. I don't think the 2020 ones have come up yet. Maybe they have. I'd have to see what ES20, if there is an ES 2020 and what might be included inside of that. I don't remember off the top of my head. And so that's what we usually mean by vanilla JavaScript. We haven't really talked anything the Snam. I'm gonna say it's Snam. You haven't missed anything. I'm just messing around and chatting about the dev tools. No worries, don't be sorry. No worries. You're free to come hop in and out as much as you want. It's totally fine. So that's what we mean by vanilla JavaScript. React is it's a library. It's more than just a library. It's a framework. Usually, what that means is a library can just be like some outside code, or is any external code you're kind of adding into your code base to like make a use of and do things with. And React's definitely that. But React goes a bit further, is that it actually has like a whole systematic approach to programming and thinking about a certain way of creating front ends and stuff like that. Like it has like its own MVC type pattern, like includes like different libraries, but also has different front end elements. It uses a templating engine to write HTML and stuff in. So you don't actually write like raw HTML in React. You write JSX, which is kind of like a JavaScript way of writing HTML. They're technically valid JavaScript documents, but it's like a way of like writing HTML through JavaScript without having to directly write that, because React's going to be doing a lot of things for you kind of auto-magically behind the scenes. It's good to be like control, like creating those elements. It's going to be updating. It creates like a whole virtual DOM for you. It's deciding like when to change that, which we'll talk more about it as well. Is one considered easier than the other? Not really an IDE. IDE is like actually like writing your code, like what you'd like write your code inside of, and like a bunch of other like stuff to like help you do that. React is more of a framework. It's like a whole series of tools and kind of a front end system to like help you write really efficient, dynamic front end code that's usually tied to some type of back end system, like some back end API or something like that. In fact, you can even go like this React, since it doesn't really care about like what the backend API is and other things like that, you can hook it up directly to like a regular API and go completely serverless. Like you could attach it to like Firebase or like other like database APIs that are out there that are popular, and kind of run all of your things kind of just from that alone. I just have to find a place to like host your React site. Kind of it's not really good. You're not like really writing your code through. It's not like React's like something that's like compiling all the things for you. Or it's not like when I think of IDE, I think of like Eclipse or like Visual Studio or things and stuff like that, that have like all these other toolkits and things around there than just like writing code. React's like a framework of like, it has a lot of it has a lot of like design philosophies and like how you write code for it, how you create front ends, like what it's trying to do. It's not philosophically neutral or design neutral. Kind of about that. Oh, API, no worries. So an API, application programmer interface. So basically, it's a programmatic way to access data and to kind of think through things. Yep, there you go. That was a great explanation of it. Definitely watch that vid. That sounds like it's a good one. Basically, it's a way for you for programs to access resources automatically, kind of through some type of programmable interface. And later on in the course, we're going to talk more about REST APIs, how that's different, and we're going to build our own. And one of your projects, your second or third project, is going to be creating your own API. You're going to be writing your own RESTful API and kind of building kind of from that and thinking about good design principles and API. So yeah, great question. Great question. Yeah, so that's kind of the difference. It's not, React isn't design neutral. It has a very much of a philosophy of how it wants you to do things and kind of fit things inside of that. So just let you know. Cool, we got a new follower. Yay. The Snam. Good to have you on board. Okay. So I don't use, I have used it in the past. I mean, I've used React. We might use it near the end of near the end of the semester if we have time. Usually near the end of semesters when we start doing more front end technologies and stuff. I'll probably do at least one lecture on React and other types of front end frameworks like it. So like there's React, there's Vue, there's Angular. There's a couple other ones that are kind of like popular with that. So they all kind of do the same concept or same idea, that are all working very similar in tandem with one another. But we will play around with them a bit. We'll talk about why they're needed. We're gonna start with kind of vanilla JavaScript because a lot of, if you want to be a great React programmer, you first need to be a great JavaScript developer. Like you really need to know your stuff around JavaScript and why it's developed this way and why React works this way and what it's trying to solve and how the base things of it. If you have a firm foundation of JavaScript as a language, picking up React or Vue or any other, whatever hot new framework or library comes down in the coming years, you'll be able to pick that up immediately. It's a lot of the same ideas. So we're trying to really build that foundation of pure JavaScript so that whatever framework and things you want to use down the line, you can do that. And the same thing like with your final project down the line. So if you want to use React in your final project, I feel like go at it. I don't think we're going to be having any programming assignments using React near the end of the semester, but you're more than welcome to use it in your final project. And I will spend at least one lecture kind of going over what it is, what it does, what it tries to solve, and like go through some of the basics and intros of like how to do it. And maybe I'll even through one of the Twitch streams this semester, be able to do like I'll go through like some of the intro tutorials and kind of play around with that as well. Cool. Okay, so this is the dev tools and some of the things that we're doing now with that. Got off on a big track there. So this is like a lot of times we're writing JavaScript and things with it. This is where we're gonna spend we would normally spend a lot of time inside of here because this is like perfect for debugging. We can stop the code. We can step through it really slowly. I could see what's in the DOM. I could see what different variables are in scope. What's in the call stack. The call stack is like what the number of like functions that are calling other functions that are calling other functions. Like what's that chain of functional calls. And like where we are inside of that, you know what I mean? And wherever I might step further in or step out. It's just there's a lot of powerful tools and stuff. And we'll talk more about this later when we start getting to actually like writing more front end code and things with that. Or like when we start talking more about like writing like actual JavaScript code for the browser, we'll be using this a lot more. So I'm not going to go into like all the other features inside of it today, just, something there to look forward to. And this is probably the other really important pane. You don't need to worry about the other tabs so much. But this is another important one. This is the network tab, and this kind of shows us all the different different network, all the things that are taking place through the network and how that's changing. So if I were to reload the web page that I called this from, I'm now reloading everything, and you can see all the fetches. And what happened there? Oh, that's weird. That changes the, oh, that's really weird. Okay. There's just a weird mouse feature that I didn't realize would do this. There. Look through all these things. Okay. So this is all the stuff that was actually called. So when a browser goes to a web page, it's not just it is downloading that HTML document, but an HTML document, especially if it's a modern HTML document, isn't just like a document by itself. it has like a million other things that it needs to build it. Like it has a CSS file that it needs to bring in. It has a bunch of JavaScript it needs to call. It has a bunch of images it needs to pull. It has a bunch of fonts and other stuff. So it's calling and absorbing all these things to reference that, to use that to build and then see this interface. And that's what everything you're seeing here. I just called one web page, and all it made. Here's the request. It made 220 requests just from asking one web page to be drawn. You know what I mean? And all the data and about 60 kilobytes of data. Or actually almost 2 megabytes of resources, having to come down and do some fun stuff with it. And so we were just kind of covering some of these things inside of here. So we have, a bunch of JavaScript. We have like some ad network stuff. We have other kind of things going through. And we actually see like in the timeline of when these events and things took place, what it was, what the actual request was, where did that request come from? Did the request come from other things and stuff? Not really hooks. No, that's more of that's another React term and stuff like that. That's usually like attaching some JavaScript to a particular element, like a button or a form or other things like that, and like hooking that in and stuff. This is just referencing from those. You know what I mean? Inside an HTML document and inside a JavaScript document, it might be calling, might need other resources to have this run. Like I might need some photos. The photos that I called, those are separate web requests. That doesn't travel. That's not embedded inside the HTML document. That's referenced by the HTML document. All the JavaScript, all the CSS, all the fonts, all these other things. The HTML document is literally just a text document. All that other media that is calling it needs other web requests to call and do those type of things. And that's what you're seeing here. And we're going to talk more about this after our JavaScript section in a few weeks. We start talking about the web standard and HTML or HTTP, the Hypertext Transfer Protocol, and talk about how this back and forth is actually taking place and some of the things. So we can see like what was asked for. So let me see if I can get like a good. I guess it's like an XML document. No, I don't want that. That's really ugly. It's got to be something better than here. No. Okay, let me try to do that again. And okay. Yeah. Okay, so I'm not really. Oh, why is it? Oh, because I have to stop. That's why. I'm an idiot. That's why I kept going over. I put the stupid break and I forgot I had the break inside of there. Try to run that again without having a break in the JavaScript code for React, and that's why like it didn't complete all these other things. Jesus God, I'm so dumb sometimes. Okay. I want to just see like the HTML document. I want to see like the base, the first thing that kicked off this whole chain. I'm not really seeing it. That's really weird. Nope. Okay. About as good as we're gonna get. I'm gonna do that by the waterfall. Okay. So here we go. This is exactly what I wanted. Great. So I was able to get that correctly. So this is the actual HTML document that we called, and this one called all the other things inside of it. So you can see from the waterfall section here, this is kind of what kicked off this event, and everything else is kind of like preceding it. And we could see a bunch of other information about like how long this took. So it's waited for a while. So we asked the server for something. The server waited for a bit. It was like this is what the stalled connection, or like the waiting for that, a couple of milliseconds for that. This waiting, or TTFB, that's time to first bit. That's the kind of lag, or the amount of time it took for between our request to the server and the server to get back with us with anything. Now that like the first bit came in, like we actually like started downloading some data, this content download talks about how long now that we heard back from the server, how long did it take to download all the data we needed to draw this web page or to do something with it. And so that, is kind of what you're seeing there. I don't want to see the log either. I want that to be fresh. Perfect. That's much better. Yeah, that's a lot better now. I was preserving the log, so I was like keeping a history of all the other times I looked at the stupid thing, and I didn't want to do that. So, it kind of lets you kind of see, this is really great for noticing like what resources are being called, where it's coming from. This is really great for finding bottlenecks, like what is the slowest part of your site, what's taking a long time to download, what's holding up other parts. You know what I mean? Where is that lag might be coming from and stuff like that. And we can also see like the requests themselves. Is there anything stopping me from copying and pasting the page's source code and using it besides the copyright? No, no, you can, anytime you have an HTML page, like, or any web document, you can completely save that and do anything you want with it. In fact, you have to just to get it to run or for you to see it, you have to have downloaded all the code and things from it anyway. And that's why it's really important if we have like secret, like information that we want to keep secret, like say like passwords or secret keys or stuff like that for like accessing secret data behind our web server or other stuff like that. Like, so like most APIs have like a secret key or like a uh, you know, some type of API key or something like that to like access, you know, authenticated information and stuff. We would never want to have that anywhere on the front end, because anyone could just right click and look inside of that or search for it. And it happens all the time for people that aren't careful, because it's super public. You know what I mean? You're going to see that inside of that. Any type of keys. That's why we'll talk about in the back end how we do authentication, how we do security, how we do other things like that, knowing that all these things are on the front side and things like that. So we just have to be really careful. And we'll talk a lot about how we protect that information on the front end, because it needs somewhere. It has, we have to get information somehow. You know what I mean? We have to know who logged in. We have to know how this stuff goes through. Information's got to get passed somehow. We're going to spend a lot of time the last few weeks of class on security and you know, different security design and other things like that, because it's just so important and it like permeates all the things we do when we make our things. But yeah, anytime you want, if you you can even see this when you go to a web page, you can right click save as, and you could save the entire web document. It'll save it usually as like a giant folder, and then you can open that that local file with a web browser as well, usually with Chrome or Safari or whatever, and then just see what was going inside of it. In fact, a lot of web archivists do that all the time. That's how if you ever used like archive.org or the Internet Archive, you mean that's how that works. You mean you kind of like see the Wayback Machine when you like look to see like what a web page was 5 years ago or whatever. The Internet Archive and the Wayback Machine, that's exactly what they're doing. You know what I mean? They're just kind of like saving all that information and stuff like that. So no stopping you from there. Great question, by the way. So inside this network tab, we can actually see what the HTTP requests were. We're going to talk a lot more. We're going to spend a lot of time on the hypertext transfer protocol and what the responses and what the requests and responses are between a browser and a server. But we can actually see them right here. We can see what the request method was. It was a GET request. We had a status code, which was a 304. That's a redirect or a permanent redirect. We have a DNS lookup to see what the actual IP address is. We have a bunch of information in the headers of like all this metadata around like our request and what we got back and stuff. I know a lot of this doesn't make sense to you right now, and most of this you can just straight up ignore because it doesn't really matter. But we're gonna get crazy deep into this stuff. You can see a preview of what this thing looks like. That's a preview of just like the raw HTML page without everything else being written inside of there, minus pictures and looks like CSS and a bunch of other stuff. So this is like just translating the HTML page directly. We can see we can actually see like a preview of what that response is. We can see what the code of that response was. We can see some initiator things like who called this? Where did it come from? What did it start? What other request chain? So like this web page called a bunch of other things. These are all the other stuff that it called, and we can kind of follow that. The timing of it, like we already talked about. And cookies, not the ones you eat. Cookies are, there we go, ways of having some local information about yourself to the front of thing. We'll talk more about cookies and stuff later on. We talk about authentication and persistence and stuff like that. Not sure if that's the right way to ask. Portions ever containerized. Do we use containers in our daily workflow? You mean like compartmentalize, like have different parts of code in different places or something like that, or like separating concerns and different things? Is that what you mean? Like having like different like separate areas of like doing type of work or like different patterns or something? Because we kind of do a little bit and stuff like that. Like that's the reason why um, what is, the point of cookies is that they're more secure than having to site store stuff about. No, cookies is meant to create some type of history about yourself to the web server. So we're going to talk about this when we talk about HTML, or sorry, I keep messing this up. HTTP. HTTP by design is uh oh god, I'm losing the stupid terminology. My brain's all like destroyed. Um, it doesn't have not persistence. That's not the word I'm looking for. Oh god, it's like right in my slides too. I'm literally going to be talking about this a whole bunch. It doesn't have any rest transactions or any transactional history about who you are. Like it treats every request exactly the same, regardless if you made it 5 times or 1 time or other things like that. Like it has no idea. It doesn't keep any oh god, or it doesn't keep any state. There we go, stateless. Oh god, I'm like destroying my brain here. It's stateless. So we don't carry states inside an HTTP. You know what I mean? It doesn't have any idea of which user was doing what or other stuff like that. A lot of the requests are stateless. So we need to, but if I'm logged in, if I'm like a special user, I need to have some way to differentiate myself from user X or this other person. Cookies is a way of trying to solve that, of a way of having some type of persistence and like creating state, but the state, instead of being stored by the server, is being stored by us on our little cookies and stuff like that. Now, there's also other ways to secure that, to make that more secure than normal. I mean, like I don't want to like store my password in a cookie or things like that. So there are like secured cookies and like other ways to hash those and stuff like that. But you know, it's not, you know, there are other areas trying to do that. So like nowadays when we think of cookies, we think of like third-party trackers and like how Google's constantly watching you over things. Because the weird thing about cookies is like, if they're not secured or not encrypted, like they should be, or they normally are for like authentication stuff, any other server can read your cookies as well. That's how Google knows you're the same person on eBay as you were if you went to like Pornhub, and know they're like, oh, you're the same person. Like you were just on Pornhub like, you know, an hour ago, and now you're on eBay. Maybe you're interested in, you know, some other activities or things. I mean, that's like how it knows that type of things about you, is how it keeps track of where you were. Because it's like reading that cookie, that local cookie from you, and then looking through things from that. So you know what I mean? It's kind of going through. So FX flags that use the platform. So many of these million. Oh, okay, yeah. That's a. I know what you're talking about for containers. So that's completely separate. That's more of like a DevOps issue. And I could have an entire course on that. So DevOps is like all about the back end infrastructure, like servers and other things like that, and like cloud services. I'm actually planning to do a course. I'd love to like create like a DevOps class that would be like a continuation of this one. But basically, it's a way to simplify different components and all the libraries and infrastructure and environment variables and things that a server or a service needs to like be turned on, like to copy it, so that we can easily push it, replace it, push it to another cloud server, replicate it a million times, you know, what have you. You know what I mean? And kind of like work through that and stuff like that. So that's what it's made for. You know what I mean? We create containers using something like Docker. And it's kind of like a way to like, instead of normally before Docker and containers, you would have to like copy an image of like the whole operating system and like all the things around it as well, like all like in like the entire operating system. But like if I just have like a microservice, if I just have like a simple database or just like this tiny server or other stuff like that, I don't want to have to copy like an entire Linux operating system just to like have that service, you know, replicated on another server or something like that. That seems like a waste. What if I could just like container, just like copy and wrap that single server, so I could put it on any type of system or any type of machine or any type of cloud provider, and then instantly have that turned on. I could make a million of it, and if I get like a ton of requests, I could duplicate and replicate that like a million times to answer a bunch of people. stuff like that. And then once you start getting like really complicated technologies, you can start like putting these different containers like they're Legos on top of one another, build really complex things. So I can have like my database container and my authentication server container and my image database, container and my front end container. Like I can start getting like all these little pieces, all the parts of my app container, each little element of that, and then link them together kind of in like they're like complex Legos. And then I can use something like Kubernetes, which is another service that kind of on top of Docker that like schedules and maintains and like helps us like replicate that complex pattern and network of containers and things together. So it's like makes a shipment or like a giant boat of containers and like lets me like put a bunch of containers and hook them up together in a certain way and then replicate that everywhere and like do other things with it or monitor it and do a bunch of other stuff. So that's a whole different thing and stuff like that. There are literally people like their entire jobs, that's all they do. That's like a whole nother separate of concerns and stuff like that around things. What about it? Why do you need my phone? There. Okay. Oh, okay. So like having kind of it's like imagine like having like functions, but like for like software services, you know what I mean? Or like infrastructure. So like imagine like you had a function, but like function around like a database or like a small API that like would let you know is this web page up or down or like logging or stuff like that. So it's kind of built and stuff around that. Yeah, that's it's super cool. I'd love to get a class into that. I use that a lot. I use Docker and Kubernetes when I'm building a lot of my services and web apps and stuff like that because it's just really convenient and allows you to do automatic scaling and other stuff. But you need to have a really deep understanding of web infrastructure and server infrastructure and like Linux infrastructure and like where the things are because it's really easy to like screw them up or to like have things disconnected or to create bottlenecks where they shouldn't be one or be able to how do you debug that to know like what is the slowest part of your system and what needs to be replicated, what can be replicated and what can't be, what does it not make sense to parallelize, etc. Okay, so that's all that stuff. God, we spent the entire hour just talking about dev tools and other things, which is fine. Like that's totally cool. This is also kind of like an open Q&A of just like chatting and doing things stuff like that. So like no worries on that front. I have if you're getting something out of it, then all the better. So let's actually write a little bit of JavaScript and kind of go through. So in class yesterday, we talked a bit. We kind of covered the different types of JavaScript, objects, arrays, strings, kind of stuff like that. So, and then also like the different types of like variables and things like that. So we talked about, like if like var x equals 5. Also, that now x, has the value of x as the number. If I do like, I don't know, oh, that's the wrong type of x. It's a number. Whoa, imagine that, but if I were to say like x now equals, I want it to be like an object, like a 3. It's really slow. Yep. Now that if I were to tire that again, oh, what? Now this type object. Amazing. Imagine that. So kind of going over different things with that. We have the different Boolean, the different types and things through. We talked about hoisting and how var and other things, stuff like that. Oh, what's 8.3? That's a great question. So that's literally just describing a different object. So what I'm saying like a semicolon something, or when I'm saying like something semicolon something else, it's just a notation. It's a way to write an object and like the value, the name of that sub attribute or that element of my object and what the value is. So, if I do a x dot a, what? It's 3. Remember we just put in that. So that like I can actually do that now. So like x dot a equals 3 because I just assigned it and created an object for that. So does that make a little more sense and stuff like that? And I now this is like dynamic. I could do other things too. So I could do like xb equals 5 for some reason. You mean, oh, what? And now if I were like to print out X, I can see that I have like 2 elements or 2 things or 2 attributes now inside that. And I just kind of like defined a different thing. Oh, I can add methods inside of there as well. So remember, JavaScript is a functional language. Excuse me. Excuse me. Too much coffee. So remember, JavaScript's a functional language. Functions are first order objects. So if I were to do something like x.f equals function that I don't know, return I misspelled return because I'm an idiot. Return cool guy. Okay, so now I'm assuming this would actually work. Ha ha ha! See, there you go, done. Amazing. I hope you're very impressed with my on the top of my head skills here for writing a quick function. It does. It's a lot like Python. Yeah. It's and you know that's right for like talking to Java. Like it's the same type of idea. Because it's object oriented stuff. So it's still don't worry about this violation thing. This is the actual from the web page I was just looking. This is from the web page, not anything we just did. So you could ignore that violation. There must be a service behind the scenes that's pinging something and it's not working. But yeah, that same terminology works here because it is objects. And they are going through. So objects have attributes, they have methods and other things like that. Though it's not really fair to call it like a method so much. It's still like an attribute because like functions are just objects. They're objects, they're data. There's things we can assign to functions or things we can assign to variables. Functions can return other functions, and other stuff like that. And we're going to get into that as well and talk about like closure and more complex stuff. Tomorrow, we're going to talk more about functions and more of the functional aspect of the language. So I hope that makes a little more sense in terms of like objects and stuff like that. Same thing like with arrays and stuff like that. Arrays are just special types of objects. So var, I don't know. Oh, let's go back. No, I don't want to do X again because I can't rewrite that. Let's do V. Equals an array. So we want like 1, 2, 3. I could have like an object inside of here. Cool. There. I don't know, hats. Why not? So this is an array. Now a bunch of stuff inside of here. And now I could do something like V, I don't know, 2. What's inside of there? 3. Imagine that. That's cool. And if I were to do 4, right? That's all they brought. Hats. Or 3. It's that object inside of there. You are cool. But arrays are also objects as well, which is really weird. So I can also do something like V dot, oh shit, what would it be? Like 1 or something. No, that's not going to work. I can also attach things to this as well. I could treat it like a dictionary. Though I didn't give it keys, so actually I can't do that here. But I can do something like V dot hat equals, I don't know, dog, whatever. And that still works. All right, look at other things inside of here. Here's a bunch of stuff inside of, going off inside of there and other things that have more complex objects in there. I could have other name value pairs, just like really complicated. Oh, it's saying undecided because it's actually returning undecided because it still has to return something. And so like any function, every time you call a function, functions do return something. That something is undefined. When I'm writing in the console live like this, all these like, if I just say like V or other stuff like that, or that one actually returns what was inside of V. But if I were to declare a new variable or other stuff like that, it's returning back undefined because there's no other thing there to return back from it. You know what I mean? It's not returning itself, but it has to return something, and it always returns undefined. That's kind of like the default thing. So I hope that makes sense. So the array thing kind of makes sense. There's a lot of cool things you can do with arrays. You can make arrays to be like complex things. I can do something like this, like v, I don't know, dog equals cat. Oh, I don't want to do that. I actually need to preview a string or something. I have to give it like a base type. I don't know, cat, whatever. So I can do that as well. So with arrays, we can switch back and forth between treating an array, accessing an array like an object. So like dog, or I can also say like the dog. I don't know why I said it like that. I'm sorry for saying dog in a weird way. I can also do that. So I can go back and forth between like treating an array like a normal object and like attributes an object, or like using this way of doing it. And I can still do things like, 0, because it's still indexed, you know what I mean? And doing like other things with that. And they don't even have to be in rows. So we could like just do all this weird thing. And I can also do things like, because it's an array, we have a bunch of other functions and stuff from it. So I could do like v dot push. I don't know. Whatevs. Getting lazy here. What? I returned back 6 because that's the number of elements now in my array. Push always returns back whatever the new number of elements or the index that we're going to find this thing at. So I'm glad the way I say dog is good for everyone else as well. You can put emojis inside of these things. Let me see. I'm gonna like copy and paste that emoji. One of this should work. I bet I could do something like, I'm gonna do something really stupid. Oh, what happened? Oh, I pressed the wrong button there. Yeah. Oh no! I thought for sure that would totally work. Darn it! Oh wait, it might work. It might work if I put it in quotes. Ha ha ha! Yeah, yeah. See if Python can do that. Can you have keys be emojis in Python? No, I don't think you can. Well, maybe you can though. I don't know that. But JavaScript can. JavaScript can do it. You can't figure that out. So yeah, that should make your day right there. You can write. Please don't write emojis in your code that you. Well, you can write it in code you turn in. Just like if I have trouble reading it and other fun things with like I make no promises of what your grade will be. The harder it is for me to read or understand what it is you're doing. Rather that like go to town. Oh, it looks like our time's almost up. So that's kind of most of what I had. I'm going to leave you with one other kind of weird tip or weird thing about JavaScript that like a lot of people get left behind on. That's the difference between like let and const and var. So remember, we can do like let equals, I don't know, s.3. So I can have things be let. That means it's not being hoisted. It's going to be stayed in that local context. Oh, can't Rust do emojis? That's not fair. No good, Rust. I'm sure. I figure most all of them can now. I wouldn't be surprised when like the latest version of C and C++ allows emojis. Like I bet, C++ 2020 or whatever the latest specs is like allows emojis for stupid things. C++ just doesn't know what it wants to be anymore. It's just like it's this weird habdash of language of like, yeah, sure, just whatever. We can like anything goes into the standard nowadays. Whatevs. So we can do things. So like, remember let like is having like a local scope and it doesn't get hoisted to the top of whatever function that it's in. Const, is for when we want immutable, objects or data that can't change. So once I assign this something, so let's say, I don't know, J5, I'm gonna sink your battleship. So once I've defined something inside of Q, I can't reassign anything that's inside of that. So I say like Q equals 3, and I can't do that. Like that's an actual syntax. That's a syntax error. that is returning from that, because I can't change anything inside of Q. It's a constant. Like it's made there to not change or be modified or do other things inside of it. Like S can change. So like S was just a let, right? So I can do like S.3 and that updates now, and that's the new thing. So I can't change constant, but that doesn't mean constant can't also change the things inside Q, or inside Q can't change. I just can't assign it something new. So if I do, so right now, Q is this object, here we go. This has this J thing. So like Q dot J equals this. But if I were to like, I want to create like a new thing inside of here, Q dot A equals, I don't know, hello. That's totally cool. I can totally do that. I'm not assigning a new space in memory for this variable thing. It all is inside the same object, and that object is mutable. I can change and modify that object and other things around it. Even the things I already signed it, that Q.J, that can equal anything I want now. That's not a const. That's just a normal attribute of this thing. So I can this one say like, I'm new. What? So const is, as long as a const is an object, the things inside of that object can grow and change and dynamically be different and things like that. So there's a clear difference in JavaScript between creating something, like creating a new object or a new instance of something, assigning something new, or changing an attribute or changing what's already there. You know what I mean? That's a different thing in memory. We can get even a little more complicated in terms of like other things changing other stuff. So if I were to do, I don't know, const O equals P, okay? Or not P, Q. Oh, no, I messed that up. Put a weird thing at the end of it. My bad. It's got giant thumbs for hands, apparently. Okay, so that's cool. So yeah, I have a new constant, and if I were to do something like O dot X equals, I don't know. Haha, what? Okay, that's in there. Do you think Q is going to be changing at all? Do you think that's going to be modified or change anything inside of Q? If there's like a Q.X? What? Yeah, it does. They're actually pointing to the same thing. They're actually this exact same object, because I said O equals Q. It's not like refer by, copy by reference or copy by object, or it's closer to reference. It's kind of like pass by reference, but not really. It's like pass by magic. Like other attributes for other things, like this doesn't work for other things. Like it doesn't work for functions. It doesn't really work for the other Boolean or the other base types and things like that. But for objects, it does. For objects, it's unique in that when we pass things around with these objects, and the way we just did, they're both pointing to the same location in memory. And so changing Q or changing O changes Q. But if I were to reassign O to something else or have it be something different, I could sever or break that connection, and it wouldn't work anymore. So just something to keep in mind. Almost guaranteed to get a question like that on the test. So don't tell anyone else that didn't attend the stream today. This is between me and my 7 favorite students on the stream right now. I'm just kidding. We'll go from there. But that's all I have for today. I don't want to keep too much more of your time watching me blather on about junk. I will see you all tomorrow morning, bright and early. Make sure to get some good rest. I hope this was useful and not boring. You got something out of it. This is also being recorded, so that's something. And I will see you all bright and early at 9:20. Have a good night. Catch you guys later.